Okay, cycle 2, week 14, cool conductors and tense pepper. This is using Cornerstone lesson plans. So the first of 2 activities is called cool conductors. You're going to be setting up 3 stations in your classroom, one with paper on the floor, piece of paper on the floor, piece of tin foil on the floor, and a carpet square on the floor that we will borrow from Summit. You will place these, around the room. They don't need to be right next to each other like this is, but you're going to have all the kids take off their shoes. So this will be our student with bare feet. So with bare feet, they are going to place 1 foot on the object and 1 foot on the floor. And I don't think it matters what floor you're using, if it's the hard, cold floor or if it's the carpet. The point is 1 foot on this product and 1 on the floor. So they're going to place 1 foot on the carpet, 1 foot on here. At the next station, 1 foot on, 1 foot off. At the next station, 1 foot on, 1 foot off. Okay? While they're going to these different stations, they're going to be filling out. And I think the little kids can do this too because you guys have so much parent help. So, and it's basically just circling. Please don't shoot the gun downstairs. Which material felt colder to your feet, or both if they felt the same. So it's just circling. So I really think even the little kids can do this, and it will be fun and give them more to do at each station if they carry their paper around to each station and they feel with their little feet, and then they take their pencil and they circle which one they think was colder. And it says to put an M if it was much colder, or S for slightly colder. So if they stand on, if they think that the floor is much, much colder than the rug, then they will circle floor. If it was much, much colder, they'll put an M. So it's pretty self-explanatory. They're going to go to the 3 stations. And then finally, they will actually stay at the 3rd station, which is aluminum foil. And they will put so they're going to put 1 sock back on. So here's my sock. They're going to put 1 sock on and keep 1 barefoot. Okay, and they're going to put both feet on the aluminum foil. And they will on their chart, you see for that station 3, both feet, it says barefoot and sock. So again, they'll say which is colder. Is it the barefoot or is it the sock foot? So it's 3 stations, but kind of 4 things to do and using the chart. So I've already printed half sheets for everybody, all the kids. So I think those would be really great to use. And there's some really great discussion about, but short. So I think it's easy, good for the little kids too, about why the surfaces feel colder and like conductors and insulators and heat. Okay, so that's the first one. The second one is about surface tension. So you're going to have a bowl. I'm trying to get to it. I'm making a video. Okay, so we're going to be talking about surface tension and hydrophilic and hydrophobic. So hydrophilic means the water, or things are attracted to water, and hydrophobic, repelled by water. So you're going to be pouring some water into a bowl. Sprinkle some, you may not see right now. You may not see. Back up. You're going to sprinkle some pepper into the water. And it says, notice that the flakes move away from each other and become mostly evenly distributed. So you're welcome to, sprinkle on as much as you want. And let me move this closer because you need to be able to see what is going on. So we have our water and our pepper flakes. And you can talk about, what's going on with the pepper? What is it mostly doing? So some of it has sunk, but most of it is floating. So you can talk about why it's floating. It's actually because of the surface tension on the water. The water is sticking together because of the shape of the water molecules. And so this, even for the little kids, you can show that this is the shape of a water molecule and it has a negative side and a positive side. So when you have more than one water molecule, they're going to stick together like magnets do. And you can maybe you could even bring in a magnet, 2 magnets, to show that they have a negative end and a positive end. And if the 2 opposite ends are near each other, then they are going to stick together, just like a magnet does. So especially for the big kids, but I think the little kids could get this too if you point out that it's similar to a magnet. So that's why the water molecules are sticking together and the pepper flakes are able to stay on the top because of surface tension. So the next thing we're going to do, you can talk about, there's a discussion about why do you think the pepper becomes evenly spaced? And again, it's because of those water molecules sticking together. And that they all have equal force. And so the equal force is pulling the flakes at about the same distance from each other. So good discussion there. And then, okay, this last thing is, this is dish soap, okay? Dish soap. And we're just going to drop 1 in and we're going to see what happens. It should be pretty instant. Here comes a drop. Whoa! That is so cool. So you saw all the pepper flakes go whoosh. So they were hydrophobic. Soap can do this because part of its molecule structure is attracted to water molecules, which is hydrophilic, while the other parts don't like water molecules, hydrophobic. And the pepper all went to the edges at the same time because the soap went into the middle of the bowl, and then the soap spread evenly in the water from the center to the edges. The water under the pepper was stuck to the pepper and didn't get soap. But if you stir the water gently with a toothpick, you'll see pepper flakes begin to sink. With the surface tension of the water lowered, the pepper won't float so easily. So I have a pencil here. I didn't grab a toothpick, but I can bring toothpicks. So I'm going to stir it, and we're going to see that a lot of the pepper flakes are going to end up sinking now because the surface tension has broken up or is lower than when it started. Yeah. Now there's a lot more that have sunk than have not. Cool. That is such a neat thing to see with the pepper in the water and then it spreading apart that if you want to do it again, you are more than welcome to, especially if you have extra time. So have fun with this.